Okay, go. Say hi.
Hi.
That is us. We are on Hoth. Here are the answers to your homeworky stuff. Please do not hesitate to ask questions. Don't hesitate to use the homework forum. Don't hesitate to do other things that will be helpful to you.
Or use the force.
And Sam says, or use the force. Okay, so here are the answers to the periodicity lecture notes ranking that you did of ionization energy. Remember that the two answers for every single question in describing why periodic trends happen are that as you go down a family, the atoms get bigger. Okay? As you go across the period, the most significant change is the increase in effective nuclear charge, meaning that that positively charged nucleus is having more of an effect on the outer electrons. Okay, so if you're ranking the elements in terms of each of the decreasing ionization energy, the way that I've found it easy is to sort of like do the greater than, less than things, okay? That makes it easier to sort of keep it straight. Okay, so here, beryllium, magnesium, and calcium, these guys are right here. Okay, so what is the most significant change as you go down this family is that the atoms get bigger. So what does that mean is going to happen? What's going to be true about the amount of energy required to pluck off one of the outer electrons from these guys? As they get bigger, that is, the atoms furthest out electrons are going to be further away from the nucleus, so it's going to be easier. So for calcium, it's going to be easier to grab that outermost electron than magnesium. For magnesium, it's going to be easier to grab it from beryllium. So this is the order I have. All right, so now, tellurium, iodine, xenon. Look at those. All right, now, as you go across the period, which is what these three are, the most significant change is the increase in effective nuclear charge. My child thinks I am weird. Okay, so if there's an increase in the effective nuclear charge, meaning that magnet that you can imagine is holding those electrons on is getting more and more powerful. So it's going to be harder to remove them. So that's why xenon has a larger first ionization energy than iodine, which has a larger first ionization energy than tellurium. Okay, for gallium, germanium, and indium. Okay, so now we're kind of comparing stuff across different things, but let's see how it works. Let's first compare indium and gallium. Which is going to be harder to remove an electron from? I would say gallium. So should you. Gallium, because how do these two compare? Well, this gallium is smaller than indium, so it's going to be harder to remove that outermost electron from it, okay? So what's going to be true about germanium versus gallium? Well, germanium has, what's the difference as you go across the period? The most significant change is that it increases effective nuclear charge, so it's going to be harder to remove the electron from germanium than gallium. Okay, and then gallium, it's going to be harder to remove from indium because it is smaller and in the same family. So this is the order I get there. All right, lanthanum, barium, cesium, and lanthanum is here. So as you go across that period, it's going to get harder. How come? Increased effective nuclear charge. Okay, how about this guy? Well, zinc, gallium, germanium. What's going to be the difference as you go across the period here? Increase in effective nuclear charge. Oh my gosh, Sam, thank you. Awesome. All right, so now what about argon, phosphorus, and indium? Well, if you were to go, indium down here is huge, right? It's a big atom, so it's, Sam agrees, it is bigger than gallium, bigger than aluminum, so it's going to be easier to pluck off that electron. And what happens as you go across the period? Okay, well, phosphorus only gets harder than aluminum, which is harder than indium to pluck off an outer electron. So then how's that going to compare to argon? Well, argon's going to be super tough to do it because as you go across this period, increased effective nuclear charge. Okay? This one sort of like is the answer right there, but it should be the same sort of situation. Okay, I hope that helps. Do not hesitate to ask questions, my friends. Okay, goodbye, stay warm, and watch out for the AT-ATs.